the chat box. We'll keep track of it, but we will wait to answer questions until the formal presentation is finished. It is your choice whether to share a video of yourself. If your internet seems to be having issues with stability, sometimes it can help if you turn off your video. And then if you're experiencing any technical issues, please send a personal chat to me or to my colleague, Riley Harris, and we'll do our best to help you quickly. To access the chat, just click on that icon that says chat at the bottom of your screen. If you enjoy learning with us tonight, we'd love for you to join us at one of our upcoming lectures. On February 24th, there'll be a presentation about fish and water temperature with Kirsten Underwood. She's a fish and wildlife biologist with U.S. Fish and Wildlife Services Gulf of Maine Coastal Program. On March 3rd, there's a presentation on sea level rise with Susie Arnold. She's a marine scientist with the Island Institute. And then on March 31st, there'll be a presentation on astronomy with Southern Maine astronomers. Our lectures are on Thursdays at 6 p.m. To learn more or sign up, visit kennebecaestuary.org/upcoming events. So I want to also give a big thank you to this evening's sponsor, the Merrymeeting Bay Trust, as well as to KELT members and donors who support our educational program like tonight's, and also support and care for our public preserves, more than 25 miles of trails, and the protection of habitat for wildlife and people. So thank you for making our work possible. If you'd like to support KELT with a donation, the easiest way to do that is to hop on over to our website at kennebecaestuary.org and click on the support menu to give securely online. There are also options to give monthly. So with all of that said, I'd like to introduce tonight's speaker, who is Danielle Frechette. Danielle is a marine resource scientist with Department of Marine Resources Division of Sea Run Fisheries and Habitat. She serves as the DMR liaison for a new community science effort tracking presence and absence of rainbow smelt and tomcod in Maine's coastal streams and rivers to inform restoration and management actions. Danielle is also lead biologist for the Salmon for Maine Rivers program, an exciting new endeavor designed to help jumpstart recovery for federally endangered Atlantic salmon in Maine. She's a salmon biologist by training and worked on endangered coho salmon and threatened steelhead salmon in California and Atlantic salmon in Quebec before landing at the DMR in 2019. So welcome, Danielle, and thank you so much for joining us this evening.
Hey, Ruth. I'm really excited to be here to talk about smelt, especially because one of the first things I did when I landed back in Maine after leaving Quebec was actually to attend a KELT lecture on sturgeon back when we could all meet in person. So it's kind of fun to feel like a little bit like I'm coming kind of full circle here. As Ruth mentioned, I'm pretty new to rainbow smelt. But it's a really fascinating and beautiful little fish. And why is my computer? There we go. Okay. They're a cold water schooling fish. So they travel around in schools and they can survive in water that's as cold as less than a degree Celsius to around 20 degrees Celsius. And one of the things that I think is so fascinating about them is they make an antifreeze protein, which is actually glycerol, to improve their swimming speed and muscle function at those really cold temperatures. They're a pretty small fish. They're actually our smallest sea run fish here in Maine. They're on the order of 4 to 13 inches long. Here in Maine, they're usually around 6 inches long. They can live up to 8 years. But here they usually live around 5 years, and again are less than about 10 inches long. They are found anadromously, so in a sea run form, in the Northeast. You can kind of see that orangey area there. Historically, they range from Chesapeake Bay all the way up to Labrador, but with climate change and development, they're kind of shrunk to we're sort of more Northeast range now. There are also freshwater or landlocked forms that occur naturally in both the Northeast and Canada. They've also been introduced to many of our freshwater systems, particularly around the Great Lakes, and this has sometimes been done for landlocked salmon management. These fish are ecologically really important. They provide a food source for a wide range of marine and freshwater species, ranging from Atlantic cod and Atlantic salmon to sea trout, Atlantic gray seals, striped bass, and many water birds like the great blue heron you see there. They're also both culturally and economically important. The earliest record of smelt was by Captain John Smith, actually, in 1622. And he wrote that smelts were so plentiful that the Native Americans would harvest the fish by simply scooping them up in baskets. And this fish really has a long-standing tradition of fishing, both here in New England as well as in the Canadian Maritimes, really because of that high abundance that the colonists found when they arrived. So the earliest uses were actually for livestock feed and for fertilizer. And to give you a sense of how abundant they were, the French settlers in New Brunswick harvested between 50 and 60 barrels a year, which is 36 gallons per barrel along the Bouctouche River, which is pretty impressive. And that was actually just used for fertilizer. So with the advent of rail transport came the ability to transport fish from Maine and Canada down into Boston and to New York, which led to large food fish markets. So in Massachusetts, in 1853, they took over 9 million smelts out of the Charles River. In the 1870s, the smelt trade at the Fulton Market in New York City was over nearly 1.5 million pounds annually. And then in 1894, the smelt fishery here in Maine supported over 1,000 fishermen and brought in the 4th highest landings after lobster, clams, and sea herring. Fortunately, declines really started quite a long time ago. There were concern about declines of the smelt stocks as early as the 1870s. And kind of in this late 1800s, early 1900s period led actually to laws regarding smelt in many states. So you can see kind of where they were, over 1,200,000 pounds in the late 1800s down to, very, very few as we get into the 21st century. Smelt fishing in Maine today, there are kind of 4 periods. There's winter ice fishing, which here along the Kennebec River is probably the most familiar form to most people. Then in spring, there's a handheld dip net fishery, which here in really southern and mid-coast Maine in zone 1 is actually closed because of declines of smelt. But it is still rather popular, especially in down east Maine. There's also a winter and spring commercial fishery that operates only in Washington County, where they're using bag nets and gill nets. And then in the fall, there's a very small hook and line fishery in some of the rivers and coastal bays. And these fishing seasons really kind of coincide with where the smelt are at any one time. So in the winter, they're in our sheltered bays and large tidal rivers. So they come in the winter. And they're staging here, they're eating, they're getting ready for their spawning season in the spring. And so that's when people are catching them through the ice. In the spring, the adults are inshore and they're in streams and rivers. So they in the winter right now, they're coming up the Kennebec, they're feeding in the estuary, they're feeding in the river. And then once spring hits, they'll start to run up the little tributaries of the Kennebec to spawn. They'll also be in our small coastal streams at that time. And they're spawning really at the head of tide. So essentially, if you were to go up the Kennebec and then pick a tributary and go up to where you get to the head of tide, that's where you'd see them spawning. In the summer, the young of year are in the estuaries and the adults move out into coastal waters. And then in the fall, they start moving back towards shore, enter the mouths of bays and the mouths of rivers. And that's where that fall hook and line fishery would operate. So I'm going to focus mostly on the spawning runs tonight because our citizen science effort that I'm going to tell you about towards the end of this talk focuses on the spawning runs. And it's also one of the best times to actually see smelt in our rivers. And so the rainbow smelt spawn at night. And they do this between mid-March and June, depending on where you are along the coastline. So if you're in southern Maine, really from basically Penobscot Bay south, so southern and mid-coast Maine, they're going to be spawning from mid-March to April. And then as you move further down east, the spawning runs get later and later. And then in far down east Maine, they'll be spawning into June. Spawning tends to occur really starting around 4.5 degrees Celsius or about 40 degrees and peaks around 10 degrees Celsius or 50. But it's really kind of variable. And we don't have a hugely, we don't have huge handle on what exactly it is that triggers them to spawn. And that's something that we can, we leave that as a little teaser for later. One of the interesting things is that the tide cycle shifts during that long spawning period. And so high tide is not always during the darkest hours. So during the spring, those darkest hours would be midnight to 4 a.m. But a radio tracking survey that Claire Enterline did showed that 29% of the tagged smelts actually moved against the tide so that they could be at their spawning grounds during darkness. So they really, really liked the dark. That's because they have a lot of visual predators. Like you saw birds, seals, even otters and mink will grab them. So the predators they're really trying to hide from are the ones that are going to see them. So they spawn and they're pretty exposed when they're spawning. So they want to do that when it's as dark as possible, and they're hidden from all those predators. Areas that they spawn, again, I said that it's the head of tide. So what makes a good spawning area is one where you have a nice riparian corridor with trees that help keep the water cool and shade it to kind of limit algae growth. Those natural riparian areas are also trapping excess nutrients, trapping sediments and filtering out pollutants. They are a fish that's pretty susceptible to, they're pretty sensitive to different pollutants. They like swift flowing riffles because those oxygenate the water. So it also serves as kind of an attractant to the fish for spawning. And then having pools interspersed amongst those riffles allows the adults to rest between spawning efforts. The eggs that the females lay are rather sticky, and so they actually will settle out on rocks and cobble stream beds and stick to the bottom. So you're really looking for a nice cobble, kind of cobble small boulder stream bed. Most smelt around here are maturing at age 2. Some males will mature when they're only a year of age. And here in mid-coast Maine and down east Maine, we have kind of some of the older smelt than you might find further south. The males are in-season repeat spawners. This means that they will come into a stream up to the head of tide, they'll spawn one night, they'll go back out, and they might do that several times during the spawning season. And they do spawn in these large aggregations when they're in streams where they're abundant. And having multiple males spawning with one female will actually increase the success of those eggs being fertilized. Oh, you know what? I forgot to push the button, so I'll let you watch the video before I go to the next slide. This video is actually taken on a down east spawning stream by an intern, Sean Beauregard, who worked with us last spring and summer. He took most of the video and a lot of the still images you'll see in this talk. The females themselves are broadcast spawners. They're basically releasing their eggs out into the water column. They will then sink to the bottom and get stuck to the rocks, so they adhere to the rocks. And unlike the males, they only spawn once per season. And there's a phrase in fisheries ecology, which is BOFs, or big old fecund females. The bigger, older fish produce more eggs. So an age 2 female is going to produce somewhere around 33,000 eggs, and an age 3 female will produce about 70,000 eggs. And the photo you're seeing here is another photo that Sean took. It's a very large egg mat in a down east river last spring. So basically you see the rocks sticking out, you can see some kind of dark rocks, but anything that you see in the stream that's white, light colored and isn't a rock, those are smelt eggs. The eggs will hatch after 7 to 21 days, depending on how warm the water is. And the larvae are then transported really immediately downstream into the tidal zone, where they begin feeding on zooplankton. And one of the things that I find really fascinating about them is they don't really actively swim. They get moved around by the currents, but they have the ability to move vertically up and down in the water column to be able to track their food. This gives you an idea of these are, right after emerging, these little larvae, they then get bigger, and then you've got a kind of a 200 millimeter juvenile down there on the bottom. So they have, depending on where you are, depending where the smelt are, their fidelity to the spawning sites varies. So here in Maine, the spawning site fidelity is pretty low. They actually wander between streams off of the same bay. And as I mentioned before, the males will spawn more than once in a spawning season. They might actually even spawn in different streams within the same spawning season. And so as you can imagine, this kind of reduces the amount of genetic diversity among those streams because they're they're mixing around. In other places, you have much more genetically distinct populations, for example, in the St. Lawrence, Canada. This is really related to difference in spawning strategies. So they may have different streams, may have different run timing, or the fish may be selecting slightly different types of spawning habitat in those more genetically distinct populations. And then what that translates to is, this is a graph of what genetic diversity for the Gulf of Maine looks like. So you can see there are genetically distinct populations. So these little, got a map of our coastline, and these boxes with the colors show you the degree of genetic variation. So if you see a lot of green, like near Cobscook Bay, it means the fish in Cobscook Bay are pretty similar. But then if you go to down east coastal Maine, you've got a different group that's blue, and then moving to Penobscot Bay, we've got an orange group. Then you get to Casco Bay, and we see this really, or actually this is the Kennebec Sheepscot Complex. You see this really interesting mix. So what we're seeing in our area is a mix of fish, that have genes that link back to Penobscot Bay, that link to the down east coastal stock. You've got these light blue ones are coming from Casco Bay. So for whatever reason, we've got this interesting mix here. We also see, as you go down the coast, you see kind of more colors coming in. And this shows that there is gene flow moving along the coastline. So fish from down east are moving along the coastline and spawning in some of our coastal streams down here. One of the interesting things is that one of the reasons that this is useful for us to know is that the groupings can help us make decisions for management. So if we wanted to help enhance the smelt population by transporting smelts and trying to establish a spawning run, we can choose fish from a region that would help us to balance maintaining the distinct stocks that you see here, those distinct colors, with preserving the natural gene flow that's happening in the populations. So I mentioned at the start of the talk that smelt really used to be found as far south as Chesapeake Bay, but now they're only as far south as Long Island Sound. This led to, in 2004, rainbow smelt being declared a federal species of concern. And in 2015, they were listed as a state species of greatest conservation need under the Maine State Wildlife Action Plan by Inland Fish and Wildlife. The possible reasons that are cited for the decline are that historical overfishing. So you saw that graph, think back to that graph at the beginning where we saw that really steep decline in smelt in the late 1800s. There are threats to their habitat, so like obstruction. So for example, an estimated 2/3 of our road stream crossings in smelt habitat actually block passage. So you can see two perched culverts here. A smelt coming up this stream is not going to be able to continue further upstream into its spawning habitat. Water quality can also cause problems for smelt, as well as habitat degradation. So channelizing habitats, the way that riparian corridors used to be managed, things like that. There are also some other threats that have kind of an unknown impact. So we know that climate change is affecting smelt. They are a cold water adapted species. There may be habitat loss occurring at other life stages that we don't really have a great handle on. So for example, how loss of estuary habitat or changes to estuary habitat may affect their populations. We don't have a great handle on predation of these fish at sea or bycatch in other fisheries either. So these are all things that we're keeping an eye on and trying to get a better handle on smelt populations. So how do we keep track of smelt populations? During the winter ice fishery, we do creel surveys at DMR. So this is one of our biologists, Nate, oh my gosh, Big King, out at a smelt shack where they do surveys. So they'll survey the fishermen and ask how many fish they've caught. They'll measure the fish. Sometimes they'll measure the fish and take scale samples. They'll determine whether they're male or female. And then we've had periodic population studies where we use spike nets to catch fish, again, look at sex ratios, take genetic samples, do mark recapture studies to look at how they're moving around. And then we have the spring spawning surveys. And that is where we're gonna spend the rest of the talk, is talking about those spring spawning surveys. Oh, sorry, no, forgot. We're gonna talk about the creel surveys first. So this is what we call a fishery dependent method of tracking a population. The way that it was carried out in the late 70s and early 80s and then resumed back in 2009. It did not happen last year because of COVID, but they're out there. Actually, we've got biologists. Well, I think they were supposed to be out there tonight, but I'm guessing that the weather has changed those plans. They go to the ice camps and they subsample up to 100 fish per angler. Again, they're looking at the length, the sex, the age of the fish. So they take the scale sample and fish scales, smelt scales included, grow like tree rings, so we can figure out how old that fish is by counting the rings in the scale, and then taking a fin clip to look at that genetic stock structure. They also record the number of anglers, how long they fish, and the number of lines, and that allows them to estimate the number of fish that are staging below the ice using what we call a catch per unit effort, which is basically the total number of smelt caught per line hour of fishing. So the population studies that I mentioned are what we call a fishery independent method. So they don't depend on the fishing being done by anglers. This is where we put fike nets on the spawning grounds. There are 6 locations that have been surveyed. These studies were done from 2008 to 2015. And they were chosen, the locations were chosen to be representative of the spawning run. Again, looking at similar biological measures, size, age, sex. They also look at the genetic population structure. Those repeat spawning or tagging studies that I talked about, as well as conducting spawning site habitat surveys. And so one of the 2 things these give us is those creel surveys where we're looking at the fish before spawning. They might not survive to spawning because they get eaten by a predator, or because they get caught by a fisherman, or because they're just not recruited to the spawning population. They're just not ready to spawn. These population studies are really looking just at the fish that are spawning, that are actually actively reproducing. So they're both really useful for keeping track of the populations. Spring spawning surveys are also a fishery independent measure. They don't depend on fishing effort. And this is where we're documenting spawning in coastal streams, looking actually at where fish are spawning. These surveys also give us information on the habitat that the fish are using, like the substrate. Also any obstructions to passage, like those perched culverts that I showed you. It also gives us information on how strong each of those spawning runs are by looking at how dense the egg mats are, or how many adults are actually physically spawning. The spring spawning surveys got their start in the early 1970s. And then there was a concerted effort in the kind of early to mid 2005 to 2009 by DMR and Marine Patrol. And what they found was that out of the 279 streams that they found, 19% of them still supported strong runs. So this is comparing these 2000 surveys to the ones that were conducted in the early 70s. However, most had smaller runs or no longer supported spawning. So we kind of have these 2 snapshots in time, the early 1970s and then 2005 to 2009, and we see really a sharp decline, there's been a sharp decrease in the number of our streams that are supporting strong smelt runs. The decline was concentrated in southern Maine, lower Casco Bay, the Kennebec River, and then the east side of Frenchman's Bay. But strong spawning runs were still found in Casco Bay, the Madomic, St. George, and Penobscot rivers, and then around Pleasant Bay and Cobscook Bay. So kind of a really interesting pattern. There's still some strong runs in Casco Bay, not like immediately around it. So that's, I think, a really interesting pattern. So then this leads us into the community science surveys. These surveys have provide a really great opportunity for community science. First off, there are a lot of streams to cover, 297 streams, and we have a huge tidal coastline. Our tidal coastline is longer than California's. And so volunteers can help us survey more streams in a given year than we as biologists could get to. So in 2015, Down East Salmon Federation worked with the Department of Marine Resources to take that protocol that had been used for spring spawning surveys, and they made a few modifications to make it user-friendly for everybody, and then started recruiting volunteers to conduct those spring spawning surveys in rivers of Down East in Washington and Hancock counties. In 2020, we launched a new joint effort between DMR, the Nature Conservancy, and Down East Salmon Federation, using refresh protocols. Basically, it's the same set of data. We're collecting the same set of data, but we've kind of revamped the data sheet a little bit, and started working with the Gulf of Maine Research Institute's Ecosystem Investigation Network. So this is a platform that GMRI has developed for community science for projects that help us understand change in the Gulf of Maine and the Gulf of Maine watershed. So there are a wide variety of projects on this platform, and the spring spawning smelt survey is one of them. This survey has two key goals. We have a science goal, which is to conduct a long-term scientifically rigorous coastwide survey to identify smelt spawning presence and absence in Maine. And then our participant goal is to connect people to the sea-run smelt in Maine's tidal streams, the science of monitoring smelt, and to each other as essential partners in habitat stewardship. The data itself is archived in DMR's Marvin database and shared with partners like DSF, TNC, and also KELT. The data itself will be used to identify undocumented runs. So runs that may be in streams that hadn't supported spawning in the past, but might be supporting spawning now. It can help us prioritize streams for restoration. So for example, population restoration or culvert replacement. And importantly, the data will not be used for fishery management changes. This is really meant to help us restore habitat. And the photo that you see here on the right, this is a very large, very dense egg bed in a Down East river that there used to be an old highway, I think it was Highway 1 bridge that basically fell in there from old Route 1. And DSF worked together with the Passamaquoddy and DMR, got that bridge out of there. And I think this was taken the next year or 2 years later. It's really amazing how quickly the smelt recolonized this stream that was blocked to them for quite a while. So if you're interested in joining our coastwide survey, the steps are fairly simple. You complete a Sea-Run Smelt Citizen Science Survey training, which we will be conducting virtually again this year. We were hoping to do more in-person trainings, but have decided that the virtual option is the safest way to go. And then once you've completed your training, you can then head to the stream with a partner, either at night to look for the adult smelt as they're spawning, or during the day to look for their eggs. And you can see one of our partners here looking at an egg bed during a daytime survey. You collect the data on paper data sheets. What you're really looking for is presence, and if there's smelt present or eggs present, you're looking for the abundance, or you're looking for the absence. And honestly, the absence of smelt is just as important a piece of data for us to have as is the abundance. So of course, we want to see smelt in our streams, but zeros are very informative data too, because those give us an idea of where we may need to prioritize some restoration action. The observers are also collecting data on substrate, the depth of the water, how much canopy cover there is, how much tree cover there is. And then once at home, the data gets entered into the Ecosystem Investigation Network data portal, and that's how it gets transmitted to myself. So the timing of the surveys varies based on your geography. So for kind of this region, for basically southern and mid-coast Maine, we're looking at starting surveys around March 15th, kind of snow and weather dependent, and extending really probably until really mid-May. The run itself may only last a few nights, so visiting the stream regularly is important. So we're asking volunteers to go back to their stream once a week and survey if they 1 or 2 streams once a week, as opposed to surveying a whole bunch of streams just once, because if you're only looking at one stream once, it's very possible to miss the spawning run. So where? Any of the 297 current and historic smelt streams in Maine, especially some of our streams that have historic data but no current data. Ruth has looked at the list of streams and identified, I think somewhere around 12 or so streams within basically the KELT area that would be great streams for surveys. So if you've got questions about those streams, you can contact us. And then I'd like to put out this plug to save the date. Our spring training for Southern and Mid-Coast Maine will be March 2nd at, that should say 4 p.m. Sorry, March 2nd at 4 p.m. via Zoom. And for more information, you can also check out the GMRI's website. So with that, there are a whole group of folks that I'd like to thank here. From GMRI, we have Sarah Kern and Riley Morse-Young, who've helped us develop the survey. Josh Roy and Molly Payne-Wynn at TNC, our partner Brett Ciccatelli at DSF. We had a few undergrad interns, Jennifer and Sean, who both worked on helping us get these amazing photographs, as well as helped us fine tune the survey protocol and the online data entry to make it a little more user-friendly. And then our DMR biologist, Mike Brown, and Claire Enterline, who really spearheaded the surveys that led to this particular spawning survey. So of course, I also need to thank all of the volunteer scientists who helped us last year, and hope that some of you might be willing to join us this year. And with that, I guess I can turn it over to Ruth and Riley for questions.
Awesome. Thank you so much, Danielle. This was really neat to learn more about Smelt. We had a couple, so if anyone has any questions, please enter them into the chat now and I'll read them out loud for Danielle. We did have some that were sent before the presentation. One was a question about the name and where it came from. So the question was, are they called Smelt because of the fact that they smell? Like, does that have anything to do with where the name came from?
Oh my gosh, that's a really good question. I don't actually know, but I'm actually going to write that down to see if I can find the answer. I'm guessing it must have something to do with Old English, because I think there are smelts over in the UK, but I'm kind of fascinated to look into the name.
Another question was about fishing gear, and could you talk a little bit more about like the different type of gear that's needed for the different types of fishing?
Yeah, I don't know what just happened to that there. So in the smelt shacks, they're generally using a hook and line. Often, if you go to a smelt shack, there's usually often they'll have a bar with a whole bunch of lines. They usually let down the line with a little basically a bloodworm on it and just let it down through the ice hole and let it sit until it starts to move with a smelt. There are other folks who use like a really small kind of like a jigging rod for ice fishing. For the spring dip net fishery, it's really a big dip net where you just dip the net in and scoop them up.
Cool. Thank you. Someone had a question about the antifreeze. So they wrote, I was always told that auto antifreeze is toxic to humans. So is the glycerol that's in Smelt not toxic?
So I think what I've learned, if I'm remembering correctly with antifreeze, there's actually like additional compounds in there that make it toxic to us. Straight glycerol though is basically kind of like a syrupy, I think it's like a polymer, but it's a protein that they're producing in their blood, so it doesn't have any of those other toxic additives. So like, like you buy a bottle of ethanol at the store, it has the stuff added to it so that you're not going to drink it, right? If I'm remembering correctly, that's, I think kind of the same thing with the glycerol that's, with antifreeze.
Oh, cool. Okay. Um, Someone asked if there are any smelt spawning streams in Monsweeg Bay.
That's a good question, wasn't I would have to look at the map. Ruth, we looked at Monsweeg as a potential spawning potential spawning stream, but decided the access wasn't great. But it was a flagged spot, so it's what the current status is, I don't know, but historically, probably yes.
At the head, kind of at the head of it, probably near like where it crosses under Route 1 there.
Yeah, that was one of the sites we'd considered, right?
Yep.
Yeah, that was on our list.
Someone asked, what's the lifespan of smelt?
Usually about 8 years maximum. Around in Maine, usually around 5.
We had an interesting question. Someone asked if they ever climb fish ladders.
Ooh. Not that I know of. They are not very strong swimmers. So a very small waterfall or a beaver dam can serve as an obstacle. I haven't heard any reports of them going up fish ladders. If you had a very small gradient, like a nature lake fishway, probably, but all of the fishways I can think of, the jump is probably too big for them. Smelt that are ascending kind of steeper coastal streams really seem to only go in on the high tide. So I'll see if I can play this video again, so you can get a sense of kind of their swimming and sort of jumping ability. I mean, it's not really, they're not good jumpers.
We did have another question kind of relating to how they move. And this was asking about like if they're looking for food at any particular spot in the water column. So, you know, they can move up and down, but is there a spot where they tend to move to typically to eat, like near the top or near the bottom?
Moving up and down, they're probably moving with the zooplankton that are also vertically migrating. We call it diurnal vertical migration, where the zooplankton will move up and down in the water column, and a lot of their fish predators will also track that. So probably following the similar diel or diurnal cycle. That would be my best answer. I don't know a whole lot about the smelt at sea, and I think in general that's kind of a bit of a black box overall.
Another question, and I had typed a question similar to this, is just how far do smelt travel into the Gulf of Maine during the non-spawning part of the year? Do they go pretty far out into the Gulf? Do they hang out near the estuaries?
They're going out kind of into the near coastal waters.
Let's see. Someone asked about, given that they're preferred to move in the dark, are they drawn to the light or are they deterred by it? So if you like had a light out there.
They seem to be deterred by it. So when we're training people or doing the nighttime surveys, part of the protocol is like very briefly putting your flashlight on across the stream and then turning it off, because they'll freak out. Yeah, they want dark.
Someone was wondering, for the smelt fishing that happens today, is it typically done for food or for bait or just sport fishing?
There's some component of it that's for bait. Down east, a lot of the dip net fishing is for food, it's for sustenance. It's also a lot of tradition around it as well. In the Kennebec, it seems to be a lot of, in the winter ice fishing is a lot of about camaraderie. People, they'll eat them, but they're going and having a good time hanging out in the ice shack, catching fish, and then going home and eating what they catch.
We had another question about a specific location. Someone was wondering if the Sebasticook and Messalonskee, I'm going to say that wrong, Messalonskee, are good spawning areas.
I would have to double check our map. Off the top of my head, I can't remember. There's a lot of streams to keep straight.
Do you know if they school during the non-spawning seasons, or are they more dispersed at that time?
They're a schooling fish, so they're hanging together, probably for predator defense, safety in numbers.
Someone was wondering more about population levels and how they differ between the North and South Casco Bay area. They're wondering if, like, is it structural barriers that makes that difference, or is light pollution maybe a cause? Is there any study looking at why those two parts of the bay are different?
Off the top of my head, I don't know. There is the way the currents split, where like I could try to go back to that slide, but where the Eastern Maine coastal current kind of splits off, there's kind of a split around there. Light pollution is an interesting question and a hypothesis that I'm actually trying to figure out if we can test.
That's really cool.
Yeah.
Someone is wondering more about smelt shacks. Is there a reason that people put them all in rows along the river? Does that help, not help? Just easiest to do it that way?
Probably easiest to do it that way when you're dragging out a bunch of shacks. I don't actually know.
Someone is wondering if they could see a copy of the spawning map. Is this presentation something you'd be comfortable with us sharing?
Yeah, and there's also a report, the Smelt Concert. I'll send a copy of the report. It's the 2014 Smelt Conservation Report that has a lot of in-depth information on smelts. A lot of the things I presented tonight, you'll find in there with a lot more detail. Especially the history stuff. There's some really fascinating accounts of the smelt fishing history, not just here, but really all throughout New England. So I can send that to you, Ruth, and it can go out.
Yeah, we'll be sending out a follow-up with the recording. And so in that, I'll be sharing Danielle's contact information about the smelt survey training. Also share my information. If you're interested in counting smelt in the KELT area, I can help connect you with stream sites and permission for access and different things for some of the sites that we figured might be ideal and that we're hoping to get monitored this year. I think we're in this area, we're really hoping to assign people to the local streams and have them like adopt a stream for the season. And then I'll share that link as well.
I think it's also linked through our smelt spawning landing page on the GMRI website. So there are a few places to get that conservation report, but that's where the map came from. It's not super fine detail, but it does kind of give a sense of where they are throughout the coast.
Awesome. One other fun question was about a smelt recipe. Do you have a favorite or a good source for recipes?
So my family doesn't eat a lot of fish, not my choice, other folks in my house. So I actually haven't eaten smelt. I really need to, I need to change that. But I'm told the best way to do it is to fry it up. It's like, there are folks who refer to it as like a French fry, that it's just a delicious little fried snack.
I think I remember eating them once as a kid. We like dipped them in, I think, cornmeal maybe, and just fried them from there. Yeah.
Yep. Like just like that. That's what I've been told. I'm going to have to get around to doing it.
Well, all right. I think that's all I'm seeing for questions. Does anyone else, if if nothing else comes in, I guess we'll close up the, let me see. Oh, someone's asking, what substrates do you smelt prefer for spawning?
So they're really going for kind of a cobble substrate. So you can think of a cobble as kind of the size of like a softball. So kind of gravel cobble, small boulder. So it really kind of anywhere from like a softball to a basketball makes good smelt spawning substrate.
We just had a question about KELT. So KELT is the Kennebec Estuary Land Trust. We're glad you're able to join us tonight for our lecture. Someone's inviting you to come eat smelt with them.
Excellent.
And yeah, thank you so much for talking. This has been really great. We really appreciate it. And I thank you to everybody who provided questions. I think there were some excellent questions tonight. It's been fun to learn more. So we'll make sure we get that email sent out within the next week. And if you have any more questions after that, please feel free to send them along and I'll pass them along to Danielle or contact Danielle directly. Great.
Thanks, and I thank you for inviting me. I really do hope to see some of you at the training on March 2nd. That training will be recorded and will be available. So if you're not able to make that training, you'll still be able to participate. Watching the training is required for participation, but we will be making it available after the 2nd so that you still have a chance to participate if that time slot doesn't work for you.
Awesome. All right. Have a great night, everybody.
Thank you. Bye.